We're going to now take a look at paired t-tests and intervals. Paired t-test is a different situation where we're going to be comparing two groups, right? But this time the two groups are dependent. They're connected in some way, right? And so that could be like the measurements between husband and wife, right? Or measurements before and after some exam, as we can take a look down here, right? We call them paired samples because, again, these measurements are connected, right? Versus a two sample is a measure where we look at the difference between two means. And the groups we're looking at are independent of each other in our two sample t-tests. For paired, right, we're measuring a single mean of differences. And so what we're looking at is, as we'll see in the example, right, we actually calculate the difference between the measurements. And then we're looking at the mean, the difference, right, the mean of these differences, which you would see in this bottom row right here. But we'll take a look at that specific example after. Some common pairings, right, are, like we said, husband and wife, right, or partners, spouses, measuring the left arm versus the right arm strength, right, or left, again, different parts of related bodies, right, that there's a connection between them. Looking at twins data, right, there's a dependency with them. The most popular one, I think, is before and after, like what were you before, and then what does the data look like after some intervention, right? Or some, again, for a class would be tutoring, for a medical situation would be that you've taken some medicine, right? What were your measurements before and what were your measurements after, right? Those are all common things that we'd be looking at. And so let's go ahead and look at the example here that we have here. And again, we're going to be comparing, in this case, COVID-19, right, let's look at the question first, right? Is there evidence that the number of deaths per million from COVID-19 has decreased between May and April for European countries? So here is a sampling of European countries and the new deaths per million measured here. And so you'll see this data is paired and connected because we're going to be comparing before and after April and then after in May. Looking at within the same, right, we're looking at the same countries. And I'm not taking the average of all of them. What I'm going to do is find the difference between these two measurements here. And then you would actually calculate. We're not going to do it by hand, but that's what we would do if it was by hand. We would actually calculate the difference between these measurements and then find the average of that. And what we're checking to see is if that mean difference is equal to 0 or not equal to 0, meaning that can we actually represent or see a difference between those measurements, right? We could also do it, is this the after one greater than, is the after one less than? We could also test it that way. So it follows the same format. You have your null and alternative. And the way we write it is the mean and a difference equals 0. Like, is the difference between each of these after we find the mean equal to 0 or not? Because in this case, we're looking for the difference. Alpha is 0.01 in this case. We're running a paired t-test. We have our IRL. We don't know if it's random. It doesn't say anything about being randomly selected. So again, we have that question. Sample size is 5, so it's not greater than 30. So that's an issue for us. We're okay if we know the distribution is normal, right, from the population we're drawing from. If we're drawing this from a normal population, then we'd be okay also. But again, we're without some of that data. Independent sample size 5 is less than 5% of all European countries, so I think we're good there. But like I said, same situation. We check conditions. We're optimally that we meet them all. If not, then we have to, be careful with our interpretation, and that's it. And so for a t-test, though, for sure in StatCrunch, you need to enter the data in. So we have these two groups, April and May. So it looked like this here. Here's your April and May, and then you have your data here. You would put it in. And what's going to happen, the computer or StatCrunch is going to measure these differences. They're going to find out, is there a difference between individual countries? And so that would be stat. It's a t-stat still, paired. And again, you have to, the April to May, you put in So to run a paired t-test, you do need to enter the data. And we were checking to see, again, hypothesis, is there a difference, right? You could see if we wanted to save the differences, it would come in a column. We don't need that. It's going to run the test for us. We're going to compute. And you will see here that we get a t-stat of 1.18 and a p-value of 0.3. So that's what will get recorded, 1.18 and 0.302. There we go. And so we ended up with that t-stat and p-value. And then we now know, right, since the p-value in our alpha was 0.01 is greater than alpha, we fail to reject. No, right? And so what happens is we're saying we don't think that's true, and that's true there. That's what we're saying. We think this. We're failing to reject that. So technically we're saying we think this may be true, right? And so then that would lead us to the conclusion, right, that there is not, right? We don't have enough evidence to conclude what? We don't have enough evidence to conclude that the difference, the mean difference, right? There is a difference between measurements. There's not sufficient evidence, right, to conclude there is a difference between the months, right? Between April and May. And that's what we would have. Again, the key thing is you have to enter this data in StatCrunch in order to run it. You do need the data because it needs to calculate the differences. So you always need the data of the two groups.